In this video, we will be creating a phylogenetic tree of Nintendo game consoles. But before that, let's go over some background info. There are two types of evolutionary change, anagenesis and cladogenesis. Anagenesis is evolutionary change within a single lineage. An example of this would be a horse being small in size, growing through evolutionary change to be bigger, and then even bigger again. Cladogenesis is evolutionary change through a branching pattern or multiple lineage. The phylogenetic tree we will be creating later in the video will provide as a better example of cladogenesis. It will also be a rooted tree. A rooted tree have a common ancestor with an outgroup, order of divergence, and distance between OTUs. What are OTUs though? OTU stands for Operational Taxonomic Units, and we use them in phylogenetic trees to classify groups. The letter O, A, B, C, and D are the OTUs in this tree. But wait, what is an outgroup? An outgroup is an OTU that diverged much earlier on from the in-group. The letter O is the outgroup because, as we can see, it diverged much earlier on in the tree. Each black dot on the tree represents an internal node, and we will go over them again later on. Let's create our phylogenetic tree now. We will create a phylogenetic tree based off of game console, specifically Nintendo game consoles. Let's identify the outgroup. The outgroup will be a PlayStation because while it is a gaming console, it is not made by Nintendo. Here's what our tree looks like so far. Let's create a cladogenesis for Nintendo consoles now. Nintendo consoles can be separated into home consoles and handheld consoles. Home consoles can diverge to the GameCube into the Nintendo Switch. The Nintendo Switch can further separate into Nintendo Switch Lite. The red-blue Nintendo Switch and the gray-gray Nintendo Switch variation diverge from this as well. That does it for home consoles. Let's move on to the handheld consoles now. Handheld console can separate to the DS and to the Game Boy. Let's start with the DS. The DS can diverge to the DS Lite and to the DSi. Let's finish this tree with the Game Boy. It can diverge to the Game Boy Advance and to the Game Boy Color. Here is our complete phylogenetic tree. Remember when we talked about OTUs earlier? The game consoles are the OTUs. This phylogenetic tree also shows cladogenesis because all the divergence are across multiple lineage. Now is a good time to go over internal nodes. Internal node shows where the OTUs diverge and represents a common ancestor of the OTUs. We can use them to find the most recent common ancestor. For example, the Game Boy Advance and the Game Boy Color most recent common ancestor is this node here, the Game Boy. If we were to look at the red-blue Nintendo Switch variation and the Nintendo Switch Lite, the most recent common ancestor would be this node here. When it comes to branch length, you can see that the DS Lite and the DSi branch length is shorter than that of the Game Boy Color and Game Boy Advance. That is because the divergence to the DS Lite and to the DSi happened more recently than the divergence of the Game Boy Color and Advance. That does it for our game console's phylogenetic tree. Thank you for watching.